If we look at the following setup, we can see from what we know about substitution reactions that this is probably going to proceed according to the SN2 reaction. We're probably going to get a product where this OH group is going to be attacking that carbon, and this bond is going to go to this bromine. We're probably going to get something looking like that, which would give us an alcohol. Along with a sodium bromide. But if we actually run this reaction, we notice that we get some side products that we don't yet have an explanation for. We would end up with something that looks like this. Plus more sodium bromide. How does that happen? What's going on here? Well, what happens here is we can have elimination reactions that will compete with our substitution reactions. Often they will be occurring in the same reaction at the same time, though we can vary the rates with some other factors. What we need to understand is the different mechanisms that elimination reactions can occur by. That'll help us understand which substitution reactions they're going to happen in tandem with. And just like in substitution reactions, we're going to have two mechanisms that are going to vary by their rate laws. So in elimination reactions, we're going to have the E1 and the E2. Nice and simple, E for elimination. 1 is going to stand for a first order reaction rate. So the rate of the E1 reaction will be fully dependent on the substrate. And we could really consider this to be in direct competition with happening alongside the SN1 mechanism. The E2 reaction here, I'm just going to put a little barrier there. It's going to have a second order rate law where it's going to matter about the substrate. And in the SN2 reaction, we would have said the nucleophile, but here it's not going to matter so much about it being a nucleophile. It's going to matter about it being a base. And we're going to see why as we dig into this a little more. The E2 reaction is going to be in direct competition most often with the SN2 reaction. So we can see what's happening here just by looking at our products and our reactants. We start with a bromine as a functional group, and we're left with an alkene. What happens here is that this functional group leaves. It's taken away. Something causes it to leave, while we also have a hydrogen here that also gets taken away. So the hydrogen and the bromine leave, resulting in two carbons that bond together. So let's start looking at the mechanisms here, since a lot of what we're going to be looking at is going to be based on what we already know about the SN1 and SN2 mechanisms. We'll start with the E2 mechanism.